Okay, chapter 5 deals with antiderivatives and integration. So, first section, talk about antiderivatives. And if you think of reverse operations such as multiplying, dividing, adding, subtracting, they're reverse operations. So is the antiderivative and the derivative. So the antiderivative is just the reverse operation. So we're working backwards. What happens is when we take the antiderivative, we are actually coming up with a family of antiderivatives. So keep in mind that the derivative of a constant say f of x equals 3, f prime of x equals 0. So when you're working backwards, this constant could be any number. So that's why we're saying that we have a family. So you're working backwards. So find all the antiderivatives of x. Well, you have to think of what can you take the derivative of that will equal x. So what happens is where we used to subtract 1, we add 1. And if I take the derivative of this, it's going to bring a 2 out in front, so I need a 1/2. And again, it's a family, so I use the capital C to represent constant. The book will use uses this lowercase k. So think about match problem 1 and the notes above there. So go ahead and do that. So integral is just used to represent that family of antiderivatives. So it's that kind of squirrely symbol. It's called an integral sign. What you're taking the integral of is called the integrin. And again, this constant at the end has a formal name. It's called the constant of integration. So using the notation, if you look at the integral of x squared dx equals x to the third divided by 3 plus c, since the derivative of x to the third over 3 plus c equals x squared. So it's just working backwards. Working backwards. They are reverse operations. So here are some basic functions, and I kind of explained it in my first example. Rather than when we take the derivative, we subtract 1. When you take the integral, you add 1, and then you divide by that. The integral of e to the x is e to the x because the derivative of e to the x is e to the x. And the integral of x to the negative 1, or 1 over x, think about what did we take the derivative of that gave us 1 over x, but it was natural log. Okay, and again, they're families, so you have to add the plus c. When we have a constant, you can bring it out in front, just like we did with derivatives. And if you're taking the integral of a sum or difference, it's the integral of the first term plus or minus the integral of the second term. So fairly simple. Here's some examples already done for you. Integral of 7 dx is 7x plus c. Make sure you put the plus c on the end. The integral of 4e to the t dt is 4 times that integral of t. And then the same thing in c, you bring the 3 out front. And again, make sure you put the plus c on the end. If you have a polynomial, again, you can split that up. So this one we have to finish. So this is 2 times the integral of x to the third dx minus 3 integral of x dx plus the integral of 4 dx. So x to the third is x to the fourth, add 1, and then I have to divide by that. Add 1, divide by that, and then our plus c, and then maybe just simplify that by saying 1/2 x to the fourth minus 3/2 x squared plus 4x plus c. Okay, I'm going to have you go ahead and try the match problem set, A, B, C, D. You'll have some questions. I'm going to go ahead and do E for you. When you look at the last one, think of this as 5 times the integral 1 over x dx minus 4 the integral e to the x dx. The integral of 1 over x is natural log. So this would be 5 times the natural log of x minus 4 e to the x plus c. Okay, using our properties, think of anything with a denominator that we can write that as a negative exponent, and then you can still use the same properties. You add 1, adding 1 to -4 is -3, and then you still need to divide by that. Plus c. Changing radicals to exponents. So this is t to the 2/3. Whatever you're taking the root of is the denominator of your fraction. So again, you add 1. So adding 1 to 2/3 is 5/3. You divide by that. When you divide by that, it's the same as multiplying by the reciprocal. So this would be 12/5 t to the 5/3 plus c. Keep in mind, you can always take the derivative of that to see if you get what you're trying to take the integral of. So long as we have one monomial in our denominator, we can split a binomial or trinomial, whatever, in the numerator. So you see how we can split that. So this is the integral of x squared minus the integral of 2x to the -2. And naturally, we should have our dx's in here. I sometimes forget. So this is 1/3 x to the third. And as you do more and more of these, you just get better at them, recognizing things. Okay, I think that's right. And then the last one, again, writing them as exponents, then you can split it. So add one. Add one. And then let's simplify. 3x to the 2/3 minus 4x to the 3/2, and we have to put our plus c on the end. For some reason, I'm feeling like this one up here is not right. Okay, so let's go ahead and do your matched problems. Again, remembering those properties. And while I did not go over this last one, what you need to do is actually distribute and create a polynomial rather than two factors. You can't integrate two factors. Not quite this way. We will get into substitution, but this one doesn't quite work that way. So when you distribute, you actually get that. And then you should be able to integrate each term. And this ends the first part of antiderivatives.